another Touch Designer tutorial. Today we're going to look at Gaussian splatting using the new pop family. I'm going to preface this tutorial by saying that I am using the experimental release 2025-31310, which was released just a couple of days ago. I'm using it on a Mac, but it should also work on a PC. And what's really great about this release is as we get closer to having a stable release, we're getting a lot of updates that are really great. I haven't been able to get Gaussian splats running super stably using pops up to this point. So this has worked a lot more stably and effective for me, which I'm super happy about. And what we're going to do today is go through the Gaussian splat component as well as looking into some of the guts of this. I'm going to make this base file where you can just load and look at Gaussian splats available for free on my Patreon. You just have to sign up to be a free member, and there'll be some added extras where we actually manipulate the guts, which will be available on the component tier. So let's start out by looking at the Gaussian splat component. And this is a component that has been modified from that original Tim Gerritsen component to work in tops. It was made available via Touch Designer as part of their beta example package. And I've made some additions as well, which we can see here in this additional parameters. So starting out, we have the basic stuff. We have the render resolution. We also have this Gaussian splat.ply. So this is where we load in a ply file. Let's do another image. And we can see that that is loading in really quickly, which is great. We can see that there's some cropping going on here as well, which we'll sort out later. But for now, I'll backtrack to my older file. So it's really nice and quick moving between Gaussian splat files. We have this ability to switch between a ply format and an spz format. So this gives us the ability to load in different types of files. So we can do spz or ply, depending on your preference there. So that's a useful update if you're using different types of files. Again, back to the ply. And we also have this reload. So basically, if you're loading in something that's not loaded right, you can just click that pulse. It should reload that file. We can turn on and off our auto sort. So this should all just be kind of left as is by default. On top of that, we have translate. So that would translate our point cloud in 3D space. And rotation. So we can rotate as well. I have this set up with a camera viewport, so we can also just rotate and hold middle mouse to zoom in and out, and right click and drag to drag around. We also can control the uniform scale, so how big our point cloud is, the splat size, so how big each of these individual splats are. So basically, look at this, it's a point right now, and as I bring that up, it becomes more and more elongated in that classic splat shape. And we have our alpha threshold, and this allows us to change the alpha blend. And we can see that things become a lot more harsh as we move in. So that's kind of a nice little slider to have there as well. The additions that I have made are down here. As we know, Gaussian splat files can be quite intensive on our machines. So I have this thin random added in. So this basically allows us to kind of randomly sample our point clouds, so we're not kind of crashing our computer if we have massive point clouds. And we can go really sparse, or we can go and have everything there. I've also set up this boundary delete, so we can see here that basically everything is cropped outside of that certain boundary. I'm using a length parameter to basically crop everything that's above a certain distance. And what we can do here is we can change this. So as I move this, we see more or less of that Gaussian splat. It's basically a way of just cropping it so we're kind of seeing the useful parts that we actually want to see. And on top of that, I have this boundary center. So this is going to define where the center of that boundary is. So basically that central point is what will get the distance around and delete outside of that boundary. So let's move this around. We can see that that boundary is moving. This is going to move this up and down. So you can see it kind of scans through the shape. So we want that normally at 0 for the Y, but for these ones, for the Z and the X, it will move it left and right. And then you can position that to whatever makes sense for you. Bring that down, and I want this to be centered. That looks more or less right. No, far off. Sometimes I find these angles can be weird. Okay. Not going to be forensic about that, but that's pretty good. So these are the options that you have for working with Gaussian splats just through this component in this example file. And I'm going to make this example file available for free on my Patreon. You just have to subscribe as a free member. Let's go inside and take a look at how we can make this do some more interesting things. This is the guts of the component. So this is essentially an earlier pipeline that now isn't used for getting the data from Polycam and displaying that. But basically what we have here is we have our point file in, we're putting a bunch of stuff together into these attributes, and then we're visualizing it down the line here using this Gaussian Splat GLSL vertex shader. And basically what we're putting in terms of the visual, is this point cloud with a bunch of attributes attached. And we can see what those attributes are. Let's take that into a pop to dat. And so we can see we've got our color, our length, which is added by me, the rotation, and the scale. So quite sparse when you actually think about all the data that is attached to a Gaussian splat initially. We can see here that we have all of these fields that we could be working with. So the Touch Designer team have done some great work making this much more streamlined, and we can see that all this stuff has been running pretty fast on my machine, about 50 to 60 FPS, which is great. This is the section where we actually can make changes. So we're basically looking to make changes in this section here, where everything has been defined and is being output, and we're basically just making changes on the end display. And what I've got here is I've got my delete, and so that delete has been paired with a math mix. This is one of my favorite kind of little tricks in Touch Designer. So in my math mix, I set my central point in the uniform section as a float 3. So I've got my x, y, z for my central point. And then I perform a subtraction operation. So I take that center away from the position. So that central point is going to subtract the position of each individual point. And that's going to give me the beginning of my length. And then I'm going to use a length operation to access the length. And what this really means is that it gives me a value for each point in terms of how far away it is from my central area that I've defined. So we can see here that we have this very clear boundary, and that's basically anything that is over that distance that we've defined is going to be deleted. And that just allows us to pop that into a delete. And right here we can see we've got the larger than operation. If I flip this around, we can see that instead of having the center shown, we're cutting out the center. So this is a really handy little trick that I use all the time for deleting things that are outside of a certain boundary, or even just making things have a kind of a ramp element away from the center. So I find this to be a very useful little kind of Touch Designer pop trick with this math mix to get the length and then the delete. What we can also see is I have this section here which has a bunch of stuff going on inside that I've kind of encapsulated for just making this a bit easier to look at. And if I add that to my cooking window and connect that up there, we can see that I'm adding in a couple things here. So we're adding in some noise, but we can also add in a trail. And what's really fun about this is the trail is actually going to be rendered by the Gaussian Splat renderer. And it's already got all the attributes of each of these splats, but it will then just render that as a trail or a copied series of particles. And I really like this effect where it's sort of the hybrid with the Gaussian splat and these sort of ephemeral trails. Let's go into this base, and I'm just going to delete all of this stuff. And we're going to build some stuff from scratch. Because we're working with sort of largish point clouds, we're going to have to add in quite a lot of noise to sort of see a difference. So let's move that up to around 1, and let's turn that period up something high like 5 or 7. We can fiddle with that exponent and even turn up the noise to something like 2, even higher than 1. If we animate it with our old favorite command abstime.seconds times 0.1, we can see that we are animating the noise. And I'm even going to make this bigger because it's a very big file. And then you get this sort of nice noise displacement effect. So that's an early stage, very simple technique that you can do. Other things that are equally simple but also effective are you can add in a twist. I really like this effect on a point cloud like this. So with the twist you can play with the strength, you can play with the roll off, and you can change the axes that you're applying that to. The y-axis is quite fun because that twirls it around the central point. And we can also change if we're bending it, if we're adding in these different types of controls, although not all of them work. Twist is very robust. And that's a really nice effect. You can also play with this pivot to change various factors and consider animating these using LFOs or abstime.seconds. I'm going to bring this down so it's very, very minimal. And with all of these techniques, something that's worth trying out is adding in a feedback loop. And what this will allow us to do is to basically create small changes to our system and then add that iteratively. So the feedback loop is going to be the sum of all its parts here. So we can't really see that twist, but if we add in a null and drag that back onto the feedback, turn up this twist value, we see that we have this sort of twirling whirlwind made out of all of our points. And press start, and we'll keep that going. We're going to add in a keyboard in. Bring that up to start, so now whenever we press that, it's going to reset that feedback loop. Something else I really like to do is I like to mix between multiple inputs in this feedback, and this allows it to have some of the initial signal coming through as well. To do that, I'm going to add in a math mix. I'm going to set the operation to mix ABC, and I'm going to take the in, so basically the unprocessed signal, and I'm going to put that in my second inlet of the math mix. And now what I'm going to do is I'm going to say P is my scope A input, in 1P is my scope B input, and then for the time being we can define a value. So 0 is going to be the processed version and 1 is going to be the unprocessed version. And as you move down, you will start getting stronger and stronger versions. So you have to go really low to really see that start coming through, because obviously the feedback loop is this iterative process. So when we are adding stuff that is closer to the original signal, it's going to take its cue from that. So what we want to do, rather than having a static value, is add in something that's going to be calculated for each point. And this could be anything you like, but in this instance, I'm going to go for something really simple and add in a pattern. We're going to see something's happening right off the bat. Not ideal. What I'm going to do is change my output attribute scope to mix. We can see it goes back to its original form. And under this math mix, I can go in here and choose in one mix as my scope C. Okay. And now let's tweak this a little bit. When we're working with sine curves, just make sure that the map low to high is -1 to 1. And let's animate that phase. Let's play a bit more to make this more exciting. Slower is always good. And let's actually change this high point. There we go. So this is something where you can just start being creative. You could also add in, say, more obvious twisting. Okay, we have an effect here. It's not particularly finessed, but this gives you the idea of what we can do as we start playing with these different mix modes. Something else we could do is, instead of a pattern, we could add in a noise, and I'm going to use, in my scope C, I'll just use noise in one noise. Once the noise is added, I'm going to turn my offset up to 1, and then we can start playing with that amplitude value. Remember that 1 is our unprocessed point cloud, and anything less than 1 is mixing towards that 0 value, which is our processed point cloud. And if we turn down that offset a little bit, we can add in some animation to the transform. And let's change the period on that noise. There, that's nice. Oh yeah, that's a much nicer effect. Let's even change that period up to 12. Turn down those harmonics. And instead of the twist, what we could do is we could add in a noise that's just going to displace the point cloud. So we're going to turn up the noise value, and we're going to turn up the period. So then this is just allowing certain segments through. Based on this noise value here. And as we turn this up and this down, it can become more noisy. So this is a nice way of kind of controlling what elements of your sketch are going to be sort of highlighted for these manipulations. And if you fancy it, you can also just add back that twist, or actually we already have that twist, so we can do that, but having it a little bit lower, or even changing the axes. And this allows you to have something that you can be really, really creative with. Apologies, my screen capture just died, so I'm restarting it. But basically the gist of this is we can just use these pop operations to essentially play around. And really simply here, we're not doing anything fancy. We're just mixing with a value here. So it could be a static value that you put in. Remember that 0 is our processed kind of affected signal, so that's looking really crazy because we put in some pretty big values there. And the closer we are to 1, we're getting to our unprocessed signal. But what we're doing by putting in a secondary signal, so like this in1 noise, is we're allowing these signals to sort of meld between the two. So we're not doing one or the other, but with this offset and amplitude combination, so if we have our offset at 1, we're just outputting a value of 1 for every particle. But as we start moving up, we're getting different values added in there, and then that's feeding back into the system. If we turn up that period, if we even turn it up really high, you'll see that that kind of affects different parts of the point system in a more obvious way. And so you can kind of tweak all these parameters to get something that you really like. I'm going to maneuver this twist down a bit. And I'm going to play with this noise a little bit more. Okay, and you could think about adding attractors in or any of that kind of stuff we've looked at previously, basically working with the point data, and then you get some interesting outputs. Okay, I'm liking that. The next thing I want to show you is we could add in, for example, trails for certain particles here. And I think that's a really interesting kind of effect to add in as well. But what I'm going to suggest is, because there are a large number of points here, we're going to filter that. So I'm going to take this into a delete that isn't going to be part of my chain. This will be a separate section. And then a null. On my delete, what I'm going to do is I'm going to go to the thin tab, and I'll turn on enabled, and I'm just going to drag that up really quite high, just so we have a few of these points available. And two things that we could do. One is we could add in a proximity, and this is a fun effect where we can basically connect things based on how close together they are. And in this instance, we might have to turn this up quite high. I'm going to add in an out for this, so we can add this in a little bit later. Let's pop this here and then merge them together. In fact, let's just see what this looks like on its own. And what we can see here is that basically for this, in terms of the proximity, it's not going to visualize those lines, even if they're very big. So in this case, what we would do is we would create another geo. And I want to use a line renderer on that geo. And there we go. So we can see those lines coming in. And if we add in that sort again, we can see those lines added into the mix. Might be interesting actually if we went back to our main pop and deleted a few of these as well. So let's go into this thin random. If you do alter things at this stage, important to remember to just repulse your network, because until you reset that feedback loop, these changes are sort of just adding iteratively in that feedback loop. Like you can see the colors kind of all over the place. So just reset. So the main point cloud has been thinned out. Let's go back into our FX. Let's turn this down a little bit. Put some more. Okay, that's a nice effect. We can see that the color has sort of been taken from that point cloud and it's applied to those lines. But let's go into the line and edit some stuff. So under line, we'll change the color for the near and the far. So there we go. We're now getting that full bright color, which is pretty cool. And then what you can also do is you can go in and you can alter the width near and far. So let's do like 1 and 1. And finally, if you really want to, you can go in and take a look at some of the attributes that you might have access to. So let's say we're going to scale it by the color. For whatever reason, you can get these interesting effects, or if you have like a particular size parameter that you want to use. So this is one option. And then the other option that I wanted to show you is this trail. Again, I'm going to create another out. And again, I'll have a delete because we don't want to have lots and lots of these particles trailing. Good idea to save at this point because sometimes things glitch. And let's drag this up so we have fewer particles. And I'm going to drag this into a trail. And because we have all of the same attributes on all of these trail particles, what we should be able to see when we plug it in to our second out, and then when we merge the two, so this is actually out 3, plug that into the null there. Let's reset. There might be a lot going on here. Okay, for the time being, I'm just going to disable this proximity just so we can look at this other effect. Very, very nice. And now let's take a look at these trails. So we can see that the trails have been instanced. Let's maybe make a few more of them. Yeah, that's super nice. It doesn't like when I move around, but once I have kind of set that off, it's quite stable. And now this should, if it's not going to crash on me, respond to all of the same controls as this over thing here. So if I change the splat size, the trail has that applied too. If I move that up to something like 3, the trail gets bigger. And if I change this alpha threshold, that affects the trail as well. So this is something that works kind of really nicely just for playing around with these networks. And again, use that thin random to sort of make things either less detailed and easier on your computer, or more detailed and potentially giving your computer a really, really hard time. Like this, where we can see it's definitely struggling. That is a really cool effect though. Again, you can change that uniform scale. That's basically how much is going to be revealed in the scene. Or you can turn it up. Remember to repulse. And let's turn up this thin random again. So I will make these experiments available on my Patreon under the component tier. The core of this, where it's just the base Gaussian splat pop, you can access if you sign up for a free member, but these experiments will be under component. I hope you have fun playing with these, and apologies for not making more videos sooner. I had a bad cold, so I'm just getting back into this. So also apologies if my voice is a bit croaky and I've been snuffly. But great to chat with you all, and more tutorials soon.